So over the last few days, we've talked a great deal about our chemistry portion of biochemistry. We've talked about the inorganic parts of science. We've talked about atoms and protons, neutrons, electrons. We've talked about how those things bond together to create inorganic compounds, and how inorganic compounds then come together to make organic compounds. Well, as those compounds get greater and greater and more complex, they have a much larger role to play in our biological world. So we start off our discussion with macromolecules. Macromolecules are those large molecules, macro meaning large, that we use in our daily lives in the biological world to create more things, to bring us energy, or to store energies. Macromolecules exist as polymers and monomers. Poly meaning many. If we have a polymer, that means it has lots of units of that original compound. A monomer has only one unit. So that would lead us to believe that monomers are simpler than polymers, and they are. When polymers are made, they join together lots of different monomers, and they use covalent bonds to do this. They do this through a process known as dehydration synthesis. The word synthesis means to make things. Dehydration means to remove water. Hydration, or hydro meaning water, D meaning to remove or to take. Dehydration means we're taking away waters. Macromolecules are formed with this reaction. We pull away a hydroxyl group and we pull away a hydrogen, and we remove water and put those two bonds together in that polymer, making an even greater or longer chain. This does require energy. The making of these bonds, the removal of water, does require energy to be used. It's also referred to as a condensation reaction. Now, if one exists, the opposite must also exist. So if there is a way to create bonds, there has to be a way to break bonds, and we refer to that reaction, the opposite of dehydration, as hydrolysis. Again, we break the word down. Hydro meaning water, lys meaning to tear apart, water tearing apart. It's a very simple concept. That's why we really have to know our root words, and we need to understand the concepts or the definitions of those root words that really help us out in science. Hydrolysis is where we use water to go in and break polymers apart. This actually releases energy and allows us to use it. Now, in the biological world, this is very important because you, an organism, need energy to run. You also store energy, you burn energy, you make your own energy, you develop these things. But to do that, you have to take in products from the outside world. That's where our molecules, our polymers, start to come into play. When we have polymers that come together in certain ways, we get things known as carbohydrates. Carbohydrates are macromolecules that are put together in different formats, creating different amounts of energy. There are monosaccharides, there are disaccharides, and there are polysaccharides. Mono, meaning one, might lead you to believe that it is a very simple saccharide or a very simple carbohydrate, and it is. Sugar, things like glucose and fructose, are very simple sugars. They don't give us a lot of energy because they don't have a lot of energy to give. Matter of fact, your body breaks them down very quickly and uses them up. When we get to disaccharides, they're a little more difficult to break apart. Things like sucrose, again a sugar, but a more complex sugar. It's harder to break apart. If it's harder to break apart, then you get more energy from it. This is where we look at the value of certain types of food. Very simple sugars, if you eat processed sugar, it's not really good for your body. It's not really good in a reaction. It's very quick energy, it's very easy to get to, but it's not lasting. It does not have a lot of it. Polysaccharides come together to make what we refer to as a starch. Starches are very important in the biological world, in your diets, and for all living organisms. Starches can be used in different formats to be more complex or less complex, giving you large amounts of energy or smaller amounts of energy. Either way, starches are a better energy source than, say, glucoses. Now, other formats in which can store energy other than starches are things like glycogen, cellulose, and chitin. Starches store energy in molecules that are made in plants. Things like potatoes, they're full of starch. Rice, wheat, oats, barley. These contain starches. Very much simpler forms of starches, and some have more complex forms like sweet potatoes. These are starches used for energy. The plant stores its energy there. You harvest that, you eat that, then you have the energy. When we move to glycogen, these are energy stores found in animals. Your liver actually holds most of the glycogen in your body. They use it throughout the night. That's why you wake up in the mornings hungry. You've depleted your stores of glycogen through the night. Cellulose is a very undigestible form of polysaccharide, which plants use to create their rigid structures. This is what their cell walls are made out of. And finally, we have chitin. Chitin is a very complex polysaccharide which is used by bugs to create exoskeletons and fungi to create their cell walls. Now, I know this was very quick, but this does conclude the majority of the information you need to know for your notes for today. We will have a Google Meet. If you missed it, watch this video again. Go back through that. If you're watching this video beforehand, remember, we'll talk about those things in our Google Meets tomorrow. Hopefully everybody enjoyed this video and gets a lot of information from it. Have a wonderful day.